Okay, so what we're doing this week is an extension of what we did last week, which was solving by substitution. So this week we're going to solve a system of equations by elimination. And the goal is the same, we just want to solve for x and y. We're just using a different method. So the goal here is to combine these columns and eliminate a variable to get one variable alone, and then plug it into the other, just like with a system of equations. So I'm going to get rid of those lines. So first thing I'm going to look at is, can I just combine these two and have one variable eliminated? If I add x plus x right here, that would give me 2x. That's not going to eliminate. If I add negative y minus, or positive y minus y, that will eliminate. So this system is just set up already for elimination. So I do these things. I have my method, and then other people do it a little differently, but all I do is combine these columns. So if I'm adding this 1x and this 1x, that would give me 2x. So I'm really combining. So the word combine is better than add, because sometimes we're combining negative numbers. So for the y's, if I add positive y to negative y, I would get 0. So I'm not going to write that 0 down because it'll get really messy otherwise. But that's the goal. We've eliminated a variable now. Now that's really like our new step. And then we add the 7 and the negative 3. So 7 minus 3 is 4. Divide by 2, and we get x equals 2. And so just like the other questions, we are going to solve for y. So I'm going to solve for y like this. It doesn't matter which one of these equations I plug it into. It looks like the first equation here is probably easier to plug it into. So if I use x plus y equals 7, well, x is 2 plus y equals 7. And then we just subtract. And so y is 5. So everything after the elimination step is exactly the same as last week. So this solution is 2, 5. All right, next problem here. So this one is not set up exactly the same way. So we have x and y on the same side. That's good. That's usually our elimination. It gives us the idea that we need to use elimination. And if I add the x's here, 5x plus x would be 6x. We want it to be 0. If I add these two, positive 3y minus 4y is not 0. So I need to do something to one of these equations to make it so I can eliminate one variable. And so I'll label these as 1 and 2. Oh, I'll move that aside though. I'll put it over here. So this is equation 1 and this is equation 2. What I'm going to do is I'm going to choose different colors for this so I can hopefully make it a little easier. So it looks like this x in the second equation, so it's alone. If I wanted to eliminate the 5x, I would need negative 5x on that second equation. So what I'll do is multiply this whole equation, and I have to multiply every part, otherwise it's not the same equation. But I multiply all of this by negative 5. Okay, so I go through and distribute. So negative 5 times 7 is negative 35. So I'm doing that move. Negative 5 times negative 4y is 20y. Negative 5 times x is negative 5x. So this is a positive 20. And so what I'm doing right now is making it so I can eliminate using my first and third equations. So what I'm going to do is just copy that red equation. I'll copy it down here. Equation 1. Okay, so now if I just add the columns, the x column will eliminate. So if I so now I'm working with these two equations, the first one, and then my modified second one, which is equation 3. So now I can add these two. So negative 5x plus 5x is 0. Perfect. 20y plus 3y is 23y. And then negative 35 plus 12 would be negative 23. And so we divide by 23, and the y value is just negative 1. Okay, so now we go for the the x value. So it doesn't matter which equation I use. I'm just going to use equation 1 because it's right there and not messed with a whole lot. So I would go 5x plus 3 times negative 1 equals 12. And I just solve this as I always would. So beyond the first step where I multiplied that equation by negative 5, it's all the same as substitution. Once you substitute, once you eliminate, you're just solving for the other variable. So add 3. This is 15. 5x equals 15, so 5 times 3 is 15. So my solution to this system is 3, negative 1. And I'll do several of these because usually it takes multiple examples to do them. Okay. So with these two, we have a little different situation, but let's see what we can do. So these are ramping up in difficulty. So I'm going to label these again. I'm actually going to get rid of this example. Let's call this equation 1, equation 2. And I'll use purple. So the x's won't eliminate, the y's won't eliminate, because they would have to be the same number but opposite sign. So is there a number I could multiply by one of these equations to make them match like that? So 6x and 4x, those are larger numbers than 2y and 3y. So what I'm going to do is use the 2y and 3y because I don't want to multiply huge numbers out. So I'm going to try to eliminate y first. Now, this needs to be the same number that this is. And we can multiply each equation by a number to make those the same. And that number, the easiest way to do this always is to just multiply one of them by the other number, and the other equation by the number it doesn't have. So these are directly correlated to, nope, that's not the arrow. This 3 is because of that 3, this 2 is because of that 2. So I'm just swapping the places in the equations. Now if I just multiply by 3 and 2, these would be positive numbers, so I need to make one of them negative. So it doesn't matter which one you choose, I'm going to make the 2 negative though. Okay, so on this one I'm modifying 2 equations. So let's multiply those out. I'll do equation 1 first. So 3 times 6x is 18x, plus 3 times 2y is 6y. Negative 12 times 3 is negative 36. So this is my new equation that I'm going to use. And then the second equation would be same thing. We have to distribute that 2. So negative 2 times 4x is negative 8x. Negative 2 times 3y is negative 6y. Negative 2 times 7 is negative 14. So once we've done that, we don't have to use these original equations anymore. We're just going to use these 2 new equations. And we just combine these. So the y's will eliminate. So we'll have 18x minus 8x, which is 10x. No y's, which is the goal. And then a negative 50. Okay, 10 times a number is negative 50. So that number needs to be negative, and it needs to be 5. So x is negative 5. So now I'm going to solve for y. Solving for y, I would probably use one of these original equations, but to keep this all, a little more simple on the page here, I'll use the second equation. it's going to be negative 8. I always choose that wrong pen. So it'll be negative 8 times x minus 6 times, or minus 6y equals negative 14. So now we just go through and solve this. So this is 40 minus 6y equals negative 14. It doesn't matter how you do this. I'm going to add the 14 to both sides, and I will add the 6y to both sides. The reason I'm doing that instead of getting everything away from y is so that the numbers stay positive. So this will be 54. So that's 54. This will be 0. This will be 0, and then I'll have 6y divide by 6. And y is 54 divided by 6, which is 9. So our solution to that system is negative 5, 9. So, some people will see, or some students will see like one or two of these and they're like, oh, okay, I get it. Others aren't like that, so I will do a couple more. So this one is just like the last one, the numbers don't match. And the numbers are larger too, which is going to be a little bit messy. So I will use a calculator on this one. So these problems I don't usually work out before I do these videos, so it might be a little slower, but it's okay. All right. So I'll number these just so I can reference those easily. And it doesn't matter which one you eliminate first. I will eliminate the x's first. And this 5x needs to be a multiple of 7x, and the 7x needs to be a multiple of 5x. So again, I just swap those numbers. So I put the 7 up here and the 5 down here. And one of them needs to be negative, so I'll make it the 5. And the only reason I'm making it negative is because both 5x and 7x are positive, so if I just multiply them by positive numbers, they'd stay positive. Okay, so equation 1, I'm going to distribute that 7. So I would get 35x plus 21y equals 7 times 13, which is 70, so that's 91. Yep. And then negative 5 times 7x is negative 35x. Negative 5 times 8y is negative 40y. And negative 16 times negative 5 is 80. So just like the last problem, once I do that, I don't need to use my original two equations. Okay, so now we just add these two columns. So we have no x's because those will cancel. And then 21 minus 40y is negative 19. 91 plus 80 is 171. And if I divide negative 19 out from both sides, then I get y equals negative 9. Okay, just like any other one of these questions, we use that value and we plug it in. So this one, the numbers are getting pretty big. So 35s, 20s, 91s. I'm not going to use that. So I'll use one of my originals. So I'll use 5x plus 3y equals 13. Because the numbers are smaller, it's going to be the same number, believe it or not. So we just go 5x plus 3 times my number equals 13. And so 5x minus 27 equals 13. Add 27. And we get 40 equals 5x. So x is 8. And so the solution to this system is 8, negative 9. Okay, so this problem is same idea, but now it's being asked in a different way. And it says, are these systems equivalent? So does system 1 equal system 2? So just remember, a system of equations, in our case, is just two equations. And so does this first set of equations equal the second set, meaning are they the same? So if we look at these, I'm going to try to use colors to highlight this. If you look at 3x plus 5y equals 1. Let's compare that to 18x plus 30y equals 6. So if there's a number that we could multiply by this first equation and get the second equation, then that would be the same line or the same equation. So if we look at it on the right, we have this 6 here. So the only thing I can multiply on the to the left equation is a 6 because this number is 1 right here. So that's a 1. So the only way to make it a 6 is to multiply by 6. So if I do that, let's work with it. So I would get 6, and then I have to distribute it to each part. So 5y times 6 is 30y. 6 times 3x is 18x. And so that one is definitely equivalent. So that is equal in the top equation. So now let's look at the bottom equation. 2x minus 6y equals 38, and 10x minus 30y equals 190. So is there a number we can multiply by both equations to get the other equation? If I look at the 2x and the 10x, what would I multiply by 2x to get the 10x? And the only number you could use is 5. So if I take this second equation and multiply by 5, let's see if it turns out to be the same for every number. So that first one is definitely 10x. Negative 6y times 5 is negative 30y, so that's looking good. And then 38 times 5 is, in fact, 190. So that's how you would check to see if systems are equivalent when it's asked like that. So just see if there's a multiple or a number that you could multiply by both equations to make them match. Okay, and the dreaded story problem. Just going to do one of these because they don't, there's not a lot of them in the homework section, so I don't want to dwell on these. The other work's hard enough. So it says the cost of two bottles of water and 4 apples is $5.50. The cost of 3 bottles of water and 5 apples is $7.50. Find the cost of 1 apple and the cost of 1 bottle of water. Sorry, I couldn't read my own handwriting. Okay, so just like the other questions, I always like to break these down into basically formulas directly from the sentences. So it says the cost of 2 bottles of water and 4 apples is $5.50. So that is giving you an equation directly. So it's not always like this in the questions, but often it is where it's just like it's laid out right there. So 2 bottles of water, so I'll call that 2W. The word and in nearly every case when it's set up like this means plus. So it says 2W and 4 apples is $5.50. So this would be 4A. So I'm using W for water, A for apples. Is always represents an equal, and then it's $5.50. So that sentence, even though it's in words, it's directly giving you a translation to an equation. So that would just be 2W plus 4A equals $5.50. And you can see what we're setting up here. It's going to be a system of equations. And yeah, both of these sentences are set up like that. So for the second sentence, it says the cost of 3 bottles of water and 5 apples is $7.50. So that's the same exact setup. So 3 bottles of water. So again, I'm using W instead of B. So I'll just say 3W. And is my plus sign. 5A for apples is $7.50. So now I have this system. Notice that it says find the cost of 1 apple and 1 bottle of water. So we just solve for W and A. Okay, so this system is one of the ones where we have to multiply both equations by something. So let's get rid of our 2 and the 3. I always go for the smaller numbers. What can I multiply 2 by? to make it the same number, and what can I multiply 3 by to make it the same number on both sides. So this is the one where we just swap the numbers. So I'm going to put a 3 up here, a 2 down here. One of them needs to be negative. I always make the smaller number negative. And then we just distribute. So 550 times 3 is 1650. 3 times 4a is 12a. 3 times 2w is 6w. Second equation, negative 2 times 750 is negative 15. Negative 2 times 5a is negative 10a. Negative 2 times 3w is negative 6w. So again, we don't use those original equations anymore. We use our modified ones. And then we just add these. So 6w minus 6w is 0. 12a minus 10a is 2a. 1650 minus $15, it would just be 1.5. Divide both by 2. If you have $1.50 and you want to split it, it's 0.75. So an apple is 75 cents. So next we solve for water, and that's always the easier one. So we just take one of these equations and plug in 0.75. So for that, I will use the original equation. So let's use 2w plus 4a equals 5.550. That's what I'm going to use to plug in a. So 2w plus 4 times 0.75 equals 5.50. And then we just solve. So 4 times 0.75 is 3. And then we just subtract the 3. And notice I'm going, I do realize I'm going quickly through these parts. That's because we have gone through a lot of this equation solving. Divide by 2. And so W is 1.25. So a bottle of water is $1.25 and an apple is 75 cents.